This is chapter 6.2, Properties of Parallelograms. You'll be doing the assignment pages 313 to 314, 13 through 20, 22, 24, 25 through 33. Now, if a quadrilateral is a parallelogram, then, these are these if-then statements, which are deductive reasoning. There are four things that will be true if a quadrilateral is a parallelogram. Then, and this is theorem 6.1, both pairs of opposite sides will be parallel. The second theorem, 6.2, says if a quadrilateral is a parallelogram, then the opposite sides are congruent. The third theorem, 6.3, says if a quadrilateral is a parallelogram, then its consecutive angles are the opposite angles are congruent. The fourth, theorem 6.4, says if a quadrilateral is a parallelogram, then its consecutive means one right after the other, angles are supplementary. Supplementary angles are two angles whose sum, you're adding them, is 180 degrees. And the final theorem is 6.5, and it says if a quadrilateral is a parallelogram, then its diagonals bisect each other. All right, we're going to go ahead. You're going to do all your notes on the left side. You're going to do all your work for pages 313 to 314, 13 through 20, 22, 24, 25 through 33 on the right. All right, we're going to go ahead and do the guided practice on page 313. Now, I've changed one just slightly because I want to have a little bit more, I want to do a little bit more with it. Number one said complete the statement. A blank is a quadrilateral with both pairs of opposite sides parallel. Well, that's that first theorem, 6.1. So it is a parallelogram is a quadrilateral with both pairs of opposite sides parallel. I drew a picture of that, and I also did some notation. So I drew the parallelogram PQRS. I put in my parallel symbols, a single arrow on QP and RS to show that they are parallel, and then double arrows on QR and PS, those are segments, to show that those segments are parallel. And then I just wrote in blue, a parallelogram is a quadrilateral with both pairs of opposite sides parallel. Now, this right here is the symbolic, right here is the symbolic, this right there, form of parallelogram PQRS. It has a parallelogram figure and then PQRS. It's typically, the letters are in order. And that means parallelogram PQRS. Now we're looking at number two and deciding whether the figure is a parallelogram. If it's not, we're going to explain why. Again, drawing the pictures will be helpful, particularly if you're taking your homework quiz. Here's the first figure. You got the top segment and the bottom segment are parallel, so there's one pair of sides that's parallel. But these other two segments, although they are congruent, they are not parallel. So this is not a parallelogram because there's only one pair of parallel sides. Number three's picture, despite my not so good artwork, shows that this side is parallel to this side, that's one pair, and that this side is parallel to this side, that's your second pair. So yes, this is a parallelogram. Now number four, I actually drew the picture again. The picture can be really helpful. It says complete the statement, give a reason for your answer. Because I'm talking about the answer, I don't have it written yet, but we're going to go through this. So JK is right here, and we know that that is opposite segment LM. So segment LM is opposite sides, and they're parallel, therefore they are congruent. Okay, so then we go angle MLK. So let's go ahead and highlight that. Angle MLK, right there. And we know that the angles opposite will be parallel. So angle KJM is opposite. So those two are opposite, and so they are therefore going to be congruent. Number 6 angle JK, so angle JKL, that's this angle here, is congruent to what? Well, we know the angles opposite are congruent, so it would be angle LMJ or angle JML, or just angle M would work as well. Okay, so those are parallel. And then on number 7, JN, that's right here, JN. Now that is going to be congruent to LN, but we're going to talk about why that is, and then we'll go back and fill all that in. The reason that these are parallel is because it is being bisected by KM. So these two are congruent because it is being bisected. All right, number 8 is angle MNL, MNL, that's this angle right here. Now, this is not part of the theorems for parallelograms, but because it's forming an X, the diagonals, these are vertical angles. So the angle that it is congruent to is KNJ or JNK. And then finally, number 9 is segment NM, which is right here. And that is this whole segment, KM, is being bisected by JL. The diagonal is bisecting. And so that means that NM is congruent to KN, segment KN or segment NK. I also would like you to write the symbolic notation for this particular picture, which is parallelogram. That's the symbol for parallelogram, JKLM. And I'd also like you to write what the diagonals are, so you have that vocabulary, a picture of that vocabulary. JL is one of the diagonals, and KM is one of the diagonals. Let's go ahead and write that down. Now I'm going to go back and write all of those explanations that I talked about so you have a written form of them, and then I'll turn it back on and just have it available to you. So again, number 4, just to reiterate, segment JK is congruent to LM because opposite sides are congruent. Number 5, angle MLK is congruent to angle KJM because opposite angles are congruent, the angles that are opposite one another. Number 6, angle JKL, angle JKL, this angle here, is congruent to LMJ because angles opposite each other are congruent. Number 7, again, segment JN, this one right here, segment JN, is congruent to segment LN or NL because diagonals bisect one another, and when you bisect something, it cuts it into 2 congruent parts. Number 8, angle MNL, MNL. Now this is not a theorem associated with parallelograms, but you will see that you're forming 4 angles with this X. So 1, 2, 3, 4 angles with the X, and the ones directly across from each other are vertical and they're congruent. So MNL is congruent to KNJ because they are vertical angles. And then finally, segment NM, that's this segment right here, NM, is congruent to KN because it is being bisected by diagonal JL. Now, we're going to continue on with the guided practice. So we've got page 2, this is continuing on page 313, guided practice. 10 through 12, you're told that they are all parallelograms. Numbers 10 and 11 are quite simple, so you can figure that out on your own really quickly. As soon as you're done, pause the recording. As soon as you're done, go ahead and write the. Okay, the measure of angle C is 65 degrees because opposite angles are congruent. And then if you look at the figure for number 11, HK, this is where you have diagonals bisecting one another. FK is 9, so HK is also 9. So diagonals bisect. They didn't ask for an explanation, but for your notes, it's helpful to have it. On number 12, it says find the measure of angle y. You were given x, 110 degrees. Now I actually drew this picture because this is the only example they've given you of this besides the ones in the book. You have consecutive angles. X and y are consecutive. X and z are non-consecutive. Y and z are consecutive. W and y are not consecutive or non-consecutive. When your angles are consecutive, you are going to have supplementary angles, meaning if you add 110 to a certain amount, it will give you 180. So you would say, okay, what's the measure of y? Well, 110 plus what gives me 180? That's 70 degrees. And that is this theorem right here. If a quadrilateral is a parallelogram, then its consecutive, again, that's a very important word, consecutive angles are supplementary, meaning they equal 180 degrees. So if we come back down, we can see that 110 and 70 does in fact equal 180 degrees. Now, in your assignment, you have some algebra problems. If it requires some solving, you need to show your work. For instance, if you look at 31, I actually drew a picture of it, so it would be helpful if you did it as well. You would see that 12 and x, this is a parallelogram, 12 and x are going to be congruent, and you don't have any solving, so you just write the value of x. However, 10 and 3y plus 1 are also opposite sides, opposite segments, so they're going to be congruent. So you would need to write 3y plus 1 equals 10. Then you would need to go through all of the algebra steps, all the properties of equalities, and show the work of how you solve them. I know it's a simple algebra problem, but I do want the work shown. I want you to write one last thing before we leave. I want you to look at this picture for 12, just a little practice. This is the symbolic notation for that parallelogram. Parallelogram shape, W, X, Y, Z. That's how you write it symbolically. And then I just would like you to write a little note to yourself that consecutive angles are supplementary. I have not finished 31 with you. You still have to do 31 in your assignment, but that is a little help for you to get started. Some will require work, most won't. So again, in this 25 through 33, I have not done 31. I just gave you a couple of hints. So make sure you still do 31.